Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video of MCQ series, we will discuss about the MCQs on the topic fixed beams of theory of structures. Let us start now. Question number 1. The maximum deflection of a fixed beam is dash 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 the maximum deflection of a simply supported beam. A greater than, B less than, C equal to, and D none of the above. Now here it is compared that the deflection of fixed beam and deflection of simply supported beam. Definitely deflection of fixed beam will be less than the deflection of simply supported beam. Hence, in this case, the correct answer is B less than. Question number 2. The maximum bending moment of a fixed beam is dash 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 the maximum bending moment of a simply supported beam. A greater than, B equal to, C less than, and D none of above. In this question, maximum bending moment of a fixed beam and simply supported beam are compared. Hence, in this case, you will see that bending moment of a fixed beam is also less than that of the simply supported beam. Hence, the correct answer is C less than. Question number 3. A fixed beam of span 4 meter carries a vertical downward point load of 50 kN at center. The fixed end moment will be A 50 kN meter, B 25 kN meter, C 20 kN meter, and D 40 kN meter. Now this is the standard case of the fixed beam in which you have to find out fixed end moment, and the standard formula for fixed end moment is WL by 4, which comes out to be 25 kilonewton meter. Hence, the correct answer is B 25 kilonewton meter. Question number 4. If all the loads acting on the fixed beam are in downward direction, then the nature of fixed end moments will be A hogging, B sagging, C both sagging and hogging, D any other. Now in this case, all the loads are acting vertically downward. Hence, whatever will be the fixed end movement induced at the ends, that will be of hogging nature. Hence, the correct answer is A hogging. Question number 5. A fixed beam of span 6 meter carries a downward UDL of 10 kN per meter on the entire span. The fixed end moment will be A 36 kN meter, B 45 kN meter, C 30 kN meter, and D 38 kN meter. Now in this case, this is again a standard case of fixed beam carrying a UDL on entire span, and the fixed end moment in this case will be WL square by 12. So if you put the value of WL, then you will get the answer as 30 kilonewton meter. Hence, the correct answer is C 30 kilonewton meter. Question number 6. A fixed beam of span 5 meter carries a vertically downward point load of 100 kilonewton meter at 2 meter from left end. The fixed end moment at the left end will be A 72 kilonewton meter, B 48 kilonewton meter, C 120 kilonewton meter, and D 50 kilonewton meter. This is also a standard case of fixed beam carrying a point load not at the center, and the formula for the fixed end movement at left end will be W A B square upon L square. Here A will be 2, B will be 3, L will be 5, and W is 100. Put all the values, you will get the answer as 72 kilonewton meter. Hence the correct answer is A 72 kilonewton meter. Question number 7. A fixed beam of span 5 meter carries a vertically downward point load of 100 kilonewton at 2 meter from left end. The fixed end moment at right end will be A. 72 kilonewton meter, B. 48 kilonewton meter, C. 120 kilonewton meter, and D. 50 kilonewton meter. Now this is the same question in the previous one, only the difference is in this case fixed end movement at right end are asked, and the formula for that is W A square into B upon L square. Put all the values, you will get the answer as 48 kilonewton meter. Hence the correct answer is B, 48 kilonewton meter. Question number 8. Out of the following, which are the advantages of a fixed beam over a simply supported beam? A. More strength, B. More stiffness, C. More rigid, and D. All the above. Now what are the advantages of a fixed beam on simply supported beam? It is stronger, stiffer, and more rigid. Means it has more strength, it has more stiffness, it has more rigidity. Hence all the three are the advantages. Hence the correct answer is D, all the above. Question number 9. A fixed beam of span 4 meter carries a downward point load W at center. The point of contraflexure is at dash 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 from each end. A. 0.8 meter, B. 1 meter, C. 1.2 meter, and D. 0.5 meter. Now in this case, this is a standard case of a fixed beam carrying a point load at the center. The final bending moment diagram is drawn by method of superposition by superimposing the free bending moment diagram and fixed bending moment diagram. In this case, free bending moment diagram is a triangle and fixed bending moment diagram is a rectangle. So when they are overlapped, you get a point of intersection, and that is the point of contraflexure. By equating the bending moment at that particular section as 0, we can find out the position of point of contraflexure. In this case, it is can be calculated from similar triangles, and it comes out to be 1 meter. Hence the correct answer is B, 1 meter. So you will have to calculate this. This is not a simple one. Question number 10. A fixed beam of span L carries a uniformly distributed load W kilonewton per meter on entire span. The point of contraflexure is at dash 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 from each end. A. 0.211 L, B. 0.2 L, C. 0.3 L, D. 0.311 L. This is also the same type of question, only this is the standard case of simply fixed beam carrying a UDL. So here also the free bending moment diagram will be parabolic and fixed bending moment diagram will be rectangle. So the point of intersection will be the point of contraflexure, which can be calculated by equating the bending moment at that point to 0, and you will find that it will come out to be 0.211 L from each end. Hence the correct answer is A, 0.211 L. Thank you.